Hello viewers, you are welcome to Chemistry Hangout. I want to believe you are fine today. Very quickly, if you are just watching this channel for the very first time, you're on the right channel. As far as chemistry is concerned, you are on the right channel. So if you are just watching this YouTube for the very first time, kindly subscribe to the channel. And if you are already a subscriber, I want to say welcome to another chemistry episode. It's going to be fun today, and that is why I want to urge you to watch this video to the very end. Very quickly, a lot of students have been, chatting me. They have been calling me as far as the 2023 Waec question and echo is concerned. Okay, and so what do you have for us this year? Do you have any content for us this year? Definitely, there's going to be a content for you this year. You should know Chemistry Hangout prioritize your sources. Chemistry Hangout is interested in your sources. So we are going to be dishing out a very wonderful content for this year. But before that, I thought of something, and I think it affected some students last year. The confidential report came late last year. So when we actually uploaded the video, it was weeks to the exam. And a whole lot of students, they were slow learner, and they are not familiar to titration. So they were finding it difficult to actually, within that short period of time, they were finding it very difficult to really get it. So, and that's the reason why I decided to do this, to add to the couple of videos on the channel. I have used volumetric analysis to determine relative atomic masses on the channel. I've used volumetric analysis to determine what of crystallization of a salt is on the channel. I've used it to determine, the concentration of base, concentration of acid is on the channel. And the one I felt I've not done on this channel is percentage purity. And we don't know where Waec will be coming from. So I felt, let me do this percentage purity so that if that's where Waec will be testing us on, okay, it will just be like a revision for us. And we have already done it. We understand how the calculation goes. We understand how the titration goes. So it will be easier for us. And that is the reason why I am doing this pre-Waec video. I might still be doing other volumetric analysis, titration that we have not done on the channel, so that it will be there for reference. So you can watch them all through, and you can see how those questions comes and how you can tackle them. So, and that's the reason why I decided to actually upload this video. A quick one too, for teachers that have reached out to me as regards preparation of reagents. Definitely Waec want us to prepare some reagents, even in schools where practicals are done. Bench reagents are important. My number is on the screen. I will be putting something up students that will help you to understand preparation of laboratory reagent from start to finish. Even if you are a novice, if you are just taking chemistry, you do not even study chemistry, but because of the love for the subject, you are teaching it in schools, you will need to understand how all these things are prepared. So if you are interested, you can chat me up on this very particular number. It's on the screen, it's showing on the screen. I have a massive, package as regards that I've put up some things that will help us to be able to do all those things conveniently, easily, and it will be stress-free. So it's going to be massive. The information is massive, and you would like it. We'll be talking about preparation of indicators, how you can do that on time. If you are given any molarity, if Waec comes, they give you specification, how do you prepare it? All those things are in the package. So it's going to be very massive. It's a massive information, but if you're interested, you can chat me up on this number. Thank you, and God bless you. So let's see the content I have for us for this year, so that it will be added to the volumetric analysis practicals that is on the channel already. So I call it 2023 pre-Waec titration, so that it keeps you on track. That's why I'm doing this. It keeps you on track. It keeps you fresh for Waec. You know what to practice. You don't just stay idle until the exam comes closer, is nearer. So you can work with this coupled with the one on the channel. So we have A is a solution of 0.2 mole per dm cube. B is a mixture of 12 grams of anhydrous sodium triisocarbonate 4 and sodium chloride. Put A into the burette. I've prepared all this here already. So let's quickly carry out the practical without much ado. So we have A is going into the burette. So very fast. This is A. I've prepared it. 0.2 molar. Use my further. So from here, very quickly, okay, small on that, so you can just okay, very good. Please don't forget to remove your funnel. And you can see immediately I remove the funnel, drops of the acid steam, enter the bread. So that's the reason why you have to remove the funnel, so that it doesn't increase the level of the acid in the bread. Fine, this is correct. So we pipette as indicated in the question as instructed. So this is my B. Good. You can see that you don't need to cheat in the exam. That's the reason why we are doing all this. We do it practically. We solve questions too theoretically to make you very, very, comfortable in the exam with a whole lot of confidence. Then I have my Meti orange. Let me put this here. I have my Meti orange. So I'm using 2 drops of Meti orange. I have 1 and I have 2. Good. So we start titrating now. So let's see. So be giving me signs. You can see it's giving me signs that it's about to change. So I have to be careful. You have to be careful. Can you see that now? Can you see the color change? So let's see what it is. So I have 21 here. I have 21 here, 0.20. I have 21 here, 0.20 for my rough. I have 21.20 for my rough. So I have 21.20. Don't forget our volume of pipette will be recorded. So we have our volume of pipette. That's 25 centimeter cube. We have 20, we have 25, but I'm using 25. That's the common one in schools. You can see it, 25. So that's what I'm using. So we have our indicator, very important. What is the indicator that we are using? So the indicator is Meti orange. Okay, so that's my first titration. So I pour it here. So, okay. So let me quickly refill. Let me refill. So my acid 0.2. So I refill again. You can decide to start from there if you don't want to refill, but I choose to refill so that you understand. So it's more than, you go to 0 again. Fine. So I remove the funnel. Don't forget, very important. Remove the funnel. So I pipette again the second time. Very important. Okay. Run it down. So don't forget, I refilled. I'm starting from 0, very important. So our initial readings, if I did that one, it was 0.00. I'm taking this one now, I'm still starting from 0.0. So this one is 0.002. I hope this is clear. So my 2 drops of Meti orange, then I start titrating. Okay. So I go for the second time. Go for the second time. Gently. You can see it's giving me signs already. Can see. Can you see that now? So this one is giving me 20.00. Wow. Okay. So this one is giving me 20.00. You can see the average is around 20, 21. Can you see that? So I will choose not to refill because the full length of the burette is around 50. So because of time is not on our side. You have to be time conscious too. So time is not on our side. You have to be time conscious too. Then I will just take my base. Okay. You have to be time conscious. Okay. You can see that. Okay, gently. Then we have our 2 drops of material. And don't forget, I'm not refilling. 1 and 2. Can you see that now? So if I'm not refilling, that means my initial will be where I stopped the second one from. So this will be 20.00. So I continue. Can you see that? Okay, let's see. Wow, 40.00. That's what I have here. Wow. So I have 40.00. I hope this is clear. So from there, you can now say 21.20. Yes, 20.00. That's this minus this. This minus this 2 will give me 20.00. I hope this is clear. So from there, you can now look for the average volume of RC used. Some other people can choose to do rough first, second, and third if you have that time. But me, I'm always time conscious. This is not the only practical you are doing on that day. You have 3 questions to answer. So just for you to save time, I love doing rough first and second. So we have 20.00. I'm taking this and this plus 20.00 divided by 2. So this is giving me 20.00 centimeter. Can you see that now? This is sorted already. So we move now from the result and information, calculate the concentration of B. Now let's go to B. They said B is a mixture of 12 grams of hydrosodium triisocarbonate and sodium chloride. So we don't know the mass of sodium carbonate that is there. We don't know the mass of sodium chloride that is there. That's number 1. Number 2, come to the equation of reaction. You will see it is only sodium carbonate here that is reacting with HCl, which means this very particular sodium chloride is acting as impurity there. It's acting. This one is acting as impurity because it's not reacting, it's just there. So it's acting as a foreigner in that very particular solution, because definitely they said, look at the solution. You have the mixture of the 2 of them. So sodium chloride is acting as impurity. There's an impure substance there. Okay, so if we want to calculate this now, concentration of B in mole per dm cube, they did not really give us the mass of B. We don't know it. So what do? We can decide to use our titration formula, which is Ca. That's number 1 now. Ca, you should be familiar with this. If you have been watching the video on my channel, you should be familiar with this very particular formula over NB. So, very important. Let's now bring those parameters. Ca, that's concentration of acid, is given in the question. Ca is 0.2 mole per dm cube. Va, that's the average volume of acid, that's 20.00 centimeter cube. I hope you are following. Cb, concentration of base, that's what we are looking for. Can you see that? Vb, that's the volume of base, which is the volume of pipette, 25 centimeter cube. Number of moles of acid. Go to the equation. We have 2 moles of hydrochloric acid. We have 2. Then our NB, we have 1. I hope you are following. Let me partition this so I can use. So from there, we slot all these values here. So what is our CA? 0.2 times what is our VA? 20.00 over what is our CB? We don't know. Times what is our VB? 25. Number of moles of acid 2 to 1. So making CB the subject, we're going to have 0.2 times 20, 00 times 1 over 25 times 2. So our CB becomes what? Let's see. I'm done with this. Let me just put it here. So 0.2 times 20 divided by 50. That's giving me 0.080 mole per dm cube. Can you see that? That's CB. I hope you are following. That's our CB. Now the second one says concentration of B in gram per dm cube. We are still on B. We are getting it in mole per dm cube. In gram per dm cube now. We know that our concentration in mole per dm cube is equal to our concentration in gram per dm cube over concentration in gram per mole. I want to believe we get this. So concentration in mole per dm cube, we have it already. Concentration in gram per dm cube, that's what they asked us to do. Then can do concentration in gram per mole. Since we know the sodium carbonate, we can calculate that. So very important. Let's go now. So we have concentration in mole per dm cube is given already 0. We are getting that 0 mole per dm cube. Okay, so our concentration in gram per dm cube, that's what we are looking for. That's our X. Okay, concentration in gram. All these things must be solved so that the examiner will know you know what you are doing. That's Na2CO3. We have been given our sodium, the atomic masses. So we have 23 times 2 plus 12 plus 16 times 3. And that will give us 46 plus 12 plus 48. And that will give us what? Let's see your calculator. 46 plus 12 plus 48. That's 106. So that will be 106 gram per. Please, the unit is very important. So we are looking for this now. So what do? We cross multiply. So we are going to have concentration in gram per dm cube. Now equal to concentration in mole per dm cube multiplied by concentration in gram per mole. I want to believe we are following. So concentration in gram per dm cube now equal to what? Concentration in mole per dm cube, that's 0.080 times 106. So concentration in gram per dm cube will be, let's consult our calculator. So that will be times 0.080. That's giving us 8.48. So we have 8.48 gram per dm cube. Now look at this. You see, we are actually getting an headway for the question. The mixture is 12. So the calculation has shown us that the mass of sodium tricarbonate that is there is 8.48. Can you see that? Which means I cannot determine the mass of the sodium chloride impurity that is there. Can you see that? So that's how we solve questions. And that's it. Look at it. Look at the question they are even giving us. They said mass of sodium chloride in the mixture. So let's see now. We know that the mixture, the mass of N, let me write it as number 3 so that it will be clearer. So number 3, I will say mass of NaCl plus Na2CO3 is equal to 12 grams as given in the question. So now we have gotten the mass of Na2CO3. So mass of Na2CO3 now is what? Is 8.48. So I can have mass of NaCl will be 12, which is sodium chloride, 12 minus 8.48. So the mass of sodium chloride is, let's see that, mass of sodium chloride 12 minus 8.48. That's 3.52 grams. You can see that? 3.52. Wow, that's interesting. Meaning the mass of sodium carbonate here is 8.48, which means the mass of sodium carbonate here, where is it? This is 8.48, while the mass of sodium chloride here is 3.52. So sodium chloride is the impurity that is there. Can you see that now? Now from there, we now said 4 percentage purity of sodium thiocarbonate. So this is the one that is pure, sodium carbonate, because it's the one reacting, while sodium chloride is the one that is impure. So how do I determine that? Percentage purity of sodium of thiocarbonate 4. So percentage purity. So my percentage purity will now be percentage purity will now be equal to, let me write this well. Let me just put this. You can put this to percentage purity will now be equal to, what is the mass of your, sodium chloride is the impure one now. So we are using the pure percentage purity. Sodium carbonate is the pure one now. So what is the mass of sodium carbonate that we have gotten? That's 8.48. So to be, you need to give the formula. There are marks for this. So I can say mass of Na2CO3 over mass of the mixture times 100 over 1. Can you see that? So percentage purity will now be mass of this, that's 8.48 over mass of the mixture 12, then times 100 over 1. So my percentage purity is what? Let's see how pure it is. 8.48 times 100 divided 12. That's 70.66. So let me just say 70.7%. That's the percentage purity of your sodium carbonate. The next question, that's a percentage impurity. How do you do that? You can do that in 2 ways. You can do it using the formula. You can do that. I can just say, since it is percentage purity, percentage is 100. So for me to know the impurity, I'll just say 100 minus 70.7. I'll get this percentage impurity. So I can say, let me solve it here. It's just a little calculation. So I can say percentage impurity is this, is 100 minus this. But let's go the formula way so that we see if we will be correct. So that's the last one. That's 5. So percentage impurity. The same formula, you can write that. Instead of mass of Na2CO3, it will now be mass of sodium chloride, because that's what we are looking for. So mass of sodium chloride is 3.52 over the mixture, that's 12 times 100 over 1. So let's see that. So 3.52 times 100 divide 12. Guys, that's 29.33. So approximately that will be 29 point, let's just say 3. So about 29.3%. Can you see that? If I say 100 minus this, it will still give me this. Can you see, if I add the two together, it will still give me 100. And that's how this is done. You can see it's fun solving all these things. That's why we have this channel to help us to understand all these things. So very important. That's how we can use volumetric analysis to actually determine percentage purity. Go over this video, go over it, practice it, let it keep you afresh for Waec. I'll still check some of the content on the channel. If you don't have some other questions I felt can give us, I'll still add it to the one that I have here. I love you guys. I wish you success in your exams. Okay, just keep practicing, keep watching this channel. If you are new to this channel, there are a lot of things you are missing out. So kindly subscribe. I love you guys. Go over it. You can share the video. You can comment. You can like it. Until when I'll be coming again to give us another episode in chemistry. Chemistry Hangout. Love you guys. Thank you.